This video card is a little bit weird. It has a blower fan in the middle, an axial fan on the outside, and to top it off, it has an Intel Arc GPU underneath. But all of those things made it interesting enough where we're going to review it today and do a teardown. But what really sold us this card was Newegg's in-house ad that it filmed for the Acer Predator BiFrost.
Now, let's take a closer look, shall we? Brush!
They also said this.
Both utilize a rarely seen vapor chamber to exhaust hot air as quickly as possible.
Now, I don't want to be the actually guy, but actually, vapor chambers are neither rare nor do they exhaust anything. That is actually not at all how they work, but that's okay. Acer wrote the script for Newegg, so Acer's more to blame here. Either way, Newegg also, we noticed, had fire extinguishers in the background behind the GPU box in their footage. So hopefully that was a mistake, but we were prepared for something a little spicy just in case. Always got to look at optics when you're filming what's in the background of the shot because it might convey a message. So this is the first partner model A770 reviewed. In fact, the first partner model Intel card we've reviewed, period, except for the Gunnier one that was just for the A380. So it'll be pretty fun. The card is about $400 these days. That puts it about $50 over the Intel LE, or they call it limited edition design, which is not actually that limited, it's just a name. And we're gonna be comparing the two, tearing apart the Acer card, and seeing how it looks for Intel Arc GPUs in the partner ecosystem. And the partners, by the way, incredibly important. EVGA, Asus, MSI, all these types of video card vendors are who got NVIDIA the distribution that they needed worldwide. Without them, Intel can't hope to achieve the same level of success. So this is an important step for Intel, and we're gonna see if it went well. Before that, this video is brought to you by Thermal Grizzly. Thermal Grizzly's Hydronaut and Cryonaut thermal pastes are high-performing thermal interfaces for use on CPUs and GPUs. You can bring an old card back to peak performance by repasting it and doing preventative maintenance, and Thermal Grizzly's Hydronaut is ideal for water cooling and air cooling for new and old cards alike. Cryonaut paste is one of the top performing pastes for extreme overclocking with CPUs and GPUs and has been used in several world record scoring machines. Learn more at the link in the description below. Acer's advertising for this product is really bizarre, but in kind of a fun way, not in that's incompetent and terrifying way. So it's the better kind of weird marketing. For example, they say, put on your winter coat because we've included 2 custom technologies with this GPU. Vapor chamber, rarely seen in a GPU. This technology streamlines airflow to circulate airflow, quickly and efficiently. Just to actually explain how it works this time. So hang on. This is a vapor chamber that is cut in half. It's cross-sectioned. NVIDIA actually left this with us when their thermal engineer came out. And the way they work has nothing to do with air really at all, other than air eventually dissipates the heat somehow, either from fins stacked on it, from the chamber itself, whatever. But it's just got a bunch of copper pillars or columns inside of it that help with surface area and with some structural rigidity. It normally has like a sintered powder, as you see on this one, for additional surface area for improvement to thermal conductivity. And then there's liquid inside that goes through a condenser and evaporator process, just like a heat pipe, except in a way that's effective over a large surface area. Anyway, that's how they work. It's not airflow. Fortunately, their Frostblade 2.0 fans are inspired by Bionics, or wait, maybe not that kind, but they say they're Bionics inspired. They also say the 5th gen Aeroblade fan is, quote, custom engineered all metal. We don't have a problem with that one. It's true if you look at the fan blades. And finally, they hit us with the one that most of you will probably appreciate. It says, quote, this product is not designed for cryptocurrency mining uses, with some of the paper notes that were included in the box telling us that it would void the warranty, assuming they could prove it. Somewhat ironically, there was a company once, I think I still can't name, that told us they wanted to use blockchain to install a piece of firmware on their video cards to then track what type of applications had ever been run on that card. So in the RMA process, they would be able to identify mining algorithms and then void the warranties. It's not happening here, as far as we know. I don't think anyone's doing that yet, but it seemed like a natural point to bring up. Okay, none of that stuff affects how the card performs in the review. It's just kind of fun to go through the marketing sometimes. It makes the job a little more interesting. So this has been hard to get in the US. Stock's been in and out. It's either popular or we think more likely the stock is kind of low for this. It's Acer's first discrete GPU that is being sold to the DIY market. So big step for Acer, massive step for Intel because they need this. Acer has made OEM cards in the past. They basically take reference designs from NVIDIA. They've probably done AMD. I haven't personally used one though. And they ship it. They might put a logo on it, but that's kind of it. So this is a custom design, which makes it a lot more interesting. Now, because we had trouble getting this originally when we were interested in it, we asked Vince from EVGA to buy one on our behalf because they were everywhere in Taiwan. They were all over the market. So he stopped by a local market, he grabbed one and shipped it over. Big shout out to Kingpin, or Vince from EVGA. Thank you for grabbing that for us. He's still in the GPU game, just a little bit of a different way. I guess buying them for us at markets. But we paid $600 total. That includes shipping, insurance, all that stuff to get it overseas. But you'll pay about $400 in the Western market. The Acer card advertises a higher core clock than the Intel LE. So that's why they stick the letters OC on here. It's a little bit higher clocks, and that'll boost the performance slightly. We'll see that in the review. Now it also has, because of the unique design, the potential to either be a thermal or acoustic nightmare or marvel, depending on how it plays out. Of course, it could also just be, it's fine. So we're gonna get over to the thermal testing lab and set it up and talk you through the results. So in the GPU testing part of the lab, time to get into thermal testing. For this, we do a couple of things. We test before and after disassembly. So we have a baseline without any interference or tampering whatsoever. And then we have to attach these thermocouples, thermal probes, to the PCB and different components within it for some more in-depth measurements that software will never give you. So that's done after disassembly, obviously, but we have the baseline to compare and make sure it all works the same. And whenever thermal pads or interfaces are damaged, we have like-for-like replacements for them on hand. All testing is done in a fixed ambient temperature of 21 degrees Celsius, so everything is comparable between runs, between different cards. And all we do is run 100% fixed load. We hook it up to a few thermocouple readers, which we have a few different kinds of them. This just happens to be the one that was next to the bench. And we collect the data. Once it's at steady state, we average hundreds of cells of that data, and we compare it to the other GPU in a known ambient and a controlled environment. So let's look at the thermal numbers. Here's the chart. The Intel FE GPU ran at about 73 degrees Celsius at steady state, with the Acer BiFrost GPU at 76 degrees. These are close enough as to be insignificant. It's not because of ambient. We control it heavily, but it'll come down to noise to see which did best here, ultimately. Overall, the Intel FE did better in our test for GPU thermals on a technicality, but not for everything. The internal memory sensor measured at 75 to 76 degrees for both, so these metrics are the same. The first VRM MOSFET thermal probe we placed measured at 74 degrees for Intel's LE and 65 degrees for the BiFrost, allowing the BiFrost an advantage. This may be a result of a better VRM heatsink design, which we'll learn about in the teardown later in this video. For the Intel LE card, we placed an additional thermocouple on a MOSFET that didn't have an equivalent positioning on the BiFrost, but we suspected it would be a hotspot. This one ran at 81 degrees on the LE, allowing the BiFrost an advantage. 81 is still well within spec for the FETs though, so it's not really concerning, it's just not as good. It's as simple as that. Finally, for the thermocouples that we placed on the memory, we measured about 64 to 65 degrees on the BiFrost and 70 to 73 on the LE. As usual, the internal to external sensor delta is about 7 to 10 degrees here. The BiFrost did better overall in memory and VRM thermals, with the LE doing slightly but irrelevantly better in GPU thermals. The biggest challenge with testing noise on Intel Arc GPUs is actually the software, because Intel doesn't have a formal RPM logging tool yet. And, well, you can log it through GPU-Z, but the problem is it doesn't understand the difference between the two fans on the BiFrost. So we only have one RPM, and it's actually the RPM of the smaller of the two fans, so we don't have any axial RPM. And that is where these pieces of tape come in, because we used an external laser tachometer to point at the fans and measure the RPM while it was being tested on this bench, which is built specifically for noise testing. So this has a Noctua NHP1 on it, which is awesome because it doesn't require any fans, and it can cool the CPU without any issues or noise whatsoever. And then we have a power supply that spins down the fan under low load, which this is, so that also doesn't make noise. And if we take a quick look around our noise booth here, this is our sort of temporary noise booth. We had this validated by a third party from outside of our company as being a 26 dBA noise floor, which is extremely quiet. without any AC or anything running. And that allows us to get some fairly precise measurements for the Arc card. Testing is done at a fixed 20 inches distance, as it is for all of our noise testing, and at a 26 dBA floor. And then for the testing itself, I did it the old-fashioned way. I sat down next to the card, ran the workload on it, and then used the laser tachometer to log the RPM, physically wrote it down, and then wrote down the temperature, and then wrote down the noise level, because the logging tools are really just subpar right now for this, but that's not normally a consumer concern, so let's just look at some numbers. As a refresher, here's the original Arc A770 limited edition noise to RPM response chart. At idle, the card is functionally silent while spinning at 540 RPM. The typical noise at steady state thermals is about 38 dBA, which is overall good compared to other GPUs. It's at least in the average range. And it helps that Arc GPUs are relatively low power consumption compared to the higher end stuff from NVIDIA, so it's easier to cool. There were 3 steps in between that plotted from 34 to 37 dBA. Adding the BiFrost to the screen now, idle is where it has the most trouble. The card is always running its fans, or at least ours was, and that means a constant 35 dBA at 20 inches in our test environment. That's a noticeable increase over the original room noise level. It'd be understandable under load, but this was idle. That's with the blower fan at 1100 RPM and the axial fan at 1750. Under load, at steady state, we plotted a 1350 RPM blower fan speed and an 1830 axial. That lands the card at about 37 dBA, and when both are under load, their volume is about the same, but idle, which is most of use, the BiFrost runs too loud. We think that Acer needs to fix this with a better VBIOS fan curve in the firmware. It would be a relatively easy fix. It's not a hardware problem. We also ran some game benchmarks. Typically, the difference between one card over another when they both have the same GPU at the core is quality of life features. So it's going to be things like the physical size of the card, the noise levels, the warranty support from the company that sells it, thermals, things of that nature. But gaming isn't typically on that list. The only reason the gaming changes is because of a pre-overclock, which this does have. But you're looking at normally 1 to 3% advantages, so don't expect to see a lot there, unless it's something like a Kingpin card where there's a ton of overclocking changes as well. So that's what we're going to be looking at for a quick run through games. These charts will only include 2 A770s. They'll have the A750 as well. And then if you want the full charts with all the GPUs on it, including NVIDIA and AMD competition, go check out our Arc A770 and A750 revisit with the newest drivers. That has everything for it. So let's look at the charts just briefly. In Shadow of the Tomb Raider at 1080p, we observed about a 4 FPS average improvement in the BiFrost card over the Intel LE. That's about a 3.4% uplift, which is at the upper range of what's normally possible on a board partner model without heavier modifications. In Total War Warhammer 3 at 1080p and high settings, we spotted an advantage of 2.1% for the Acer BiFrost over the Intel LE. Those are about the same as expected. Rainbow Six Siege at 1080p follows this pattern, producing about a 5 FPS lead for the BiFrost and average, and that's a 2% advantage for Acer's variation of the A770 GPU. Final Fantasy XIV had the BiFrost card at 183.2 FPS average. It's about a 2 FPS lead over the Intel LE. That's only a 1.2% advantage, so we're at the lower range of the typical deviation for partners. We have more games, but they're all the same as these. It's 1 to 3% everywhere, and that advantage is consistently in favor of the BiFrost. So let's move on to the teardown. Okay, so this is pretty straightforward. This is one of the easier designs I've ever looked at. I mean, by contrast, this thing wasn't as bad as the 30 series, but it's really not fun to put it back together. There's a lot of small pieces you might forget. So this is very standard in that regard. We are going to be doing this on one of our mod mats. You can buy one on store.gamersnexus.net, and we're going to be using one of our toolkits as well, which is designed and hand-selected with parts for GPU disassembly specifically. We're going to track the screws on a grid. Whether or not you have one of our mod mats, I would highly encourage, if you haven't done this a lot, at least get a sheet of paper and draw a grid on it and mark the screws. So, because we can already see here on the back, you know, this is a standard larger GPU screw, and then we've got at least 2 different size screws I can see here, and you don't want to mix them up. All right, so very simple. We're going to start with removing this back plate in the pieces that it's built in. So there's a longer screw. Well, that's a very short one. Okay. All right, so this is actually, this is one of the instances where I'm not just using the grid to promote our thing. I'm actually going to use that on reassembly because everything about them looks identical, but the actual screw length is very different. This one we're going to leave for now. That is a GPU screw. This one is just holding parts of the body together, so it's not going through the PCB like the others. The PCB stops right here. I'm thinking this should, oh wow, all right, that was very easy. Okay, let's see what they've done. So this is actually really good. I'm way more impressed with this than I thought I would be. So they did thermal putty, that's what this stuff is, on the filtering capacitors on the back of the VRM. So all this, you can see where it was applied. That's awesome. A lot of the video card manufacturers, including big ones like MSI, Asus, etc., they don't necessarily try to leverage their backplate. This is a low power part, relatively. Arc is not that high power consuming. So if they didn't use this, I would for sure make a comment on it. I'd say, yeah, if you have the surface area, all this metal backplate, you should use it. But then I would have said, but it doesn't matter for a couple hundred watts. In this case, they've gone the opposite direction, where they've tried to leverage extra surface area when it's not even necessary, which to me is a great indication of design competence. So that's a pretty strong start. They've got some pads here for controllers, so that's going to be a voltage controller there. And then let's see what else. More capacitors over here with thermal putty on them as well. There's a thermal pad for some of the sort of stray components that are scattered across the board. Actually, there's a thermal pad for that chip, as that IC as well. So very good start from Acer. All right, next step, now we're going to take out the rest of the screws. So these are going to be going into the base plate. I'm going to try disconnecting actually the cooler screws first. Okay, so those are out. Let's see, does this separate or do we need to? It does not. We're going to have to take the rest of the screws out. So I'm trying to track these very carefully because even just these two, they're slightly different. Now we're going to have 2 larger and 4 smaller screws to take out. All right, back plate, or the bracket rather. So now we can remove the cooler. Yep. We're gonna have 3 cables to disconnect. Those look like the pain in the ass connector, which is the technical name. So this one wasn't too bad, even though the connectors were a little bit of a pain. So this is very standard, but not, again, that's not like an insult. That's a good thing because they're dealing with a very standard amount of power that's generated in the GPU core. Where modern GPUs, modern silicon from NVIDIA, you might be dealing with 450 watts, maybe 600 when overclocked. It's a lot. And with Intel, currently you're not really going past the low hundreds. So standard design works great for that. What they have is Acer is using a vapor chamber here. You can tell because it's a chamber and there's vapor in it. But also, this is an indication of where it's sealed and vacuum shut. So that's a vapor chamber that is on the better side of cooling solutions as opposed to just a copper plate with heat pipes. Generally good attention to detail about around the board where you can see thermal putty for all of the MOSFETs right there. And if we look at the front side of the board, the putty for the MOSFETs here aligns with the putty you're seeing down here. Actually, what I just pointed to was these. These are capacitors. And then the middle one's the MOSFETs. They've got thermal putty on the inductors. This isn't too important, but if you look at the bottom of the heatsink area compared to the very last inductor, you can see that there was never any contact here. So missing some coverage on the ends of the heatsink from the inductor is not a big deal. If it were a MOSFET or a memory module, I'd be much more concerned. So that all looks good. For the memory, same thing, they're using thermal putty. It's more compressible, so there's some advantages to it. Thermal paste spread is pretty good here. It's very likely that they are using a silk screen to apply it either by machine or by hand. This is basically a perfect rectangle around the GPU. And if you look down at the GPU itself on the card, you'll see that it has pretty even spread across the whole thing. There's a little bit heavier concentration over here, but it's really not bad. And while we're down there, looking at the memory modules, these all have good contact, a little bit of a gap down here, but overall it's looking pretty good. So we've seen enough of this stuff. I want to move the PCB out of the way, and we're going to remove this base plate, that's what this part is called, from the fin stack, which is this, and take a closer look at the fans, the fan assembly, and replaceability of the fans. What side of the card are we on? We're on the south side. Oh, that was very easy. Okay, we're gonna need to take out 2 more up here. So we can pull the base plate off. They don't have any contact from the base plate to the fin stack. I would say that's an area where there's some pretty obvious improvement that Acer could make if they wanted to. This is already free. Ooh. Got that Motel 6 springy bed going for the heatsink. My only real criticism so far is going to be all the foam. I understand what they're trying to do. They're trying to reduce vibrational rattle from the fans, and it makes sense because a blower fan is going to rattle a lot more, especially when it's made out of this really thin metal. They have this thing on here about like Aeroblade trademark 3D fan or whatever. There's a reason other people don't use Aeroblade 3D fan, and it's not because Acer holds the trademark. It's because a thin blade metal squirrel cage fan next to an axial fan is going to be loud if you don't deal with the rattle. This half of the fin stack, it's all aluminum fins. They've got 4 pipes running through it. Let's go ahead and measure the size. Are they really 8s? Oh. It says 7.8, but that's an 8 mil pipe. So they have 8s there. Actually, these look like 10s. Let me just check for myself. That's a 10. Those are pretty huge. Bigger heat pipe, not necessarily better, but it can be. It just depends what they're doing. So they've got 4 going to directly over the GPU, contacting the copper cold plate to the vapor chamber. This is a good spot to be. They've got good contact on all 4 to the GPU area, so that's standard and good design. Then they've got the 2 larger pipes here hooking up to the other half of the fin stack, and that's going to be dealing with heat from the primarily the memory, which syncs to the vapor chamber as well, and then to possibly, well, the inductors will just by proxy deal with be dealt with somewhat by both halves of the fin stack, but this side is mostly going to be dealing with heat from the GPU and the memory. And now we get down to the fans. So inside the shroud, here's the axial fan. Let me flip this over. There's a logo there, a little hard to see, but that is a PowerLogic fan. PowerLogic is a fairly large manufacturer of fans. EVGA used them for years and years. So a very common maker of fans. It is a 12 volt, 0.55 amp fan, dual ball bearing for this one. So nothing abnormal there. The blower is a Delta fan, very big name in fan manufacturing. And this one is 12 volts and is that 1 amp? Holy crap. So this could be a 12 watt fan if you wanted it to be. That's insane. I haven't had this thing get that loud, but I mean, that's going to put it into the thousands of RPM possible range, and that would be an extremely loud blower fan. So down here you can see the wall. That's to project the air away from this side, because that would be pointless. It would just be going into the axial fan and causing problems. They've got a foam strip in there too, probably again to reduce vibration. And the last part up here is a PCB. This receives all the wiring, and that's going to be from the blower fan, from the axial fan here, and LEDs, and that's pretty much all there is to this card. So the BiFrost on the physical side it's built really well, we think. It's a very simple design, so there's nothing impressive in the sense of there's no like mechanical or engineering feats physically on the card that make us think this should be some kind of new design. The blower plus axial approach, there's a reason this isn't on more cards. Maybe a reason you could argue a design like this would be if you're Acer and you typically design for hot box OEM systems, you're so used to using the GPU as an exhaust path for your hot air that builds up in the case that you can't get away from it. So maybe they put it there, and this isn't in any of the marketing, but it is how it would actually work, as a means to pull in heat from the rest of the system and shoot it out the back of the card. Now that is really not efficient in terms of the GPU's performance. It actually makes it worse, obviously, but it could work in an OEM box. For a DIY system, especially one with actually good airflow, like we would recommend on our channel, this advantage, if you can call it that, becomes irrelevant. Doesn't do anything, and in fact, it might only make things a little bit worse for the GPU, but not in a way that's actually meaningful based on our testing today. Another reason you might combine these is if you're using a really large fan that takes up so much horizontal space on, say, a shorter card than this one, and you can't fit another same size axial fan next to it, you could put a smaller blower on it that would still get you 2 fans, but without making the card even wider. In this instance, they could have put another one of these fans over here, and it really wouldn't be any different in terms of the physical dimensions. In fact, it could be exactly the same. So there's no difference there. The flow-through design on the side over here, that, as far as Acer goes, that impressed us just because it's a more modern way of thinking about video cards. It's not something we would necessarily expect of a company that, frankly, it's a little bit like a dinosaur company. I mean, Acer has been around a long time. They don't typically show much quick innovation. They follow, but we don't see them at the front end of the curve normally. So that impressed us just in the sense that Acer's doing something we didn't expect them to. So that's good. Aside from the physical and the teardown aspects of this, and it being actually really easy to maintain if you ever needed to, they are $50 more expensive. So versus, say, the LE version from Intel, you're paying more. You get 1 to 3% more performance in gaming for that. It's obviously not worth it. If you wanted to, you could overclock the Intel one to get there. Same argument applies here. You could overclock the Acer one, and it's an arms race. But either way, they're functionally the same in gaming performance. You will not notice a difference visually as a human player, even though benchmarking software can see it. So noise isn't any better at load than the Intel one. They're about the same. And the noise is worse for the BiFrost card at idle. It is much louder than it needs to be. It's not loud in the sense that it's not like screaming and high-pitched whining noises coming out of the system or anything. It's probably about the same as the rest of your system noise, but it could be quieter, and it should be. And Acer would really only have to update the firmware for that and change the fan curve. So that's a little bit disappointing there because that's one of the simpler things. But overall, we think it's interesting. I guess it looks sort of interesting if you're into that. And the VRM and the memory thermals were better than Intel's LE, so that's something worth noting as well, but it's not something that will affect your performance. And the VRM and memory thermals were still well within spec on the Intel card, so it's not like it's taking it from concerning the parts are going to die to now it's better. It's taking it from this is fine to this is also fine, but technically a little bit better. Ultimately then, the main reason to buy it, we think, would just be if you are interested in the look or you can't get this one. Maybe there's a bit of an argument to be made for a really thermally constrained small form factor box because you're still retaining some of that ability to jet engine the air out the back of the GPU. But because there's an axial fan as well, they're a little bit in conflict, where instead of running one blower fan that's a higher RPM to have the stronger pressure to get stuff out, you're sort of stealing from it because they're trying to run the blower at a lower RPM, which is smart because they're obnoxious when they're high RPM, but that also takes away the function of it, in a sense anyway. And that's also typically why you see a blower at the end of the card to force all the way through the air, through the internal channels, because they're just more effective that way. But that's it for this one. It's not bad, and that actually is good for Acer. That's where they need to be. It's really good for Intel because they need some board partners here. They're kind of out there on the fringes, and Acer's joined a little bit, ASRock's starting to join, but that's it for now. So thanks for watching. As always, you can subscribe for more. Go to store.gamersnexus.net to help us with this testing by grabbing things like our mod mats that we did the teardown on, or our toolkits, or you go to patreon.com/gamersnexus. Thanks for watching. We'll see you all next time.